All right, last two examples. We'll go ahead and do one of each, one with congruence and one with supplementary. So if you're looking at 9, notice that we have angles that are on the opposite sides of the transversal. One's on the left, one's on the right, and they are outside of our two lines A and B. So they are alternate exterior angles. So we are going to use the alternate exterior angles converse here. What the alternate exterior angles converse tells us is that these two angles need to have equal measure. We need equal measure. So this is an equality example. This is another pick on the little guy problem. Our numbers are a bit bigger, but no worries. 23 is smaller than 27. So I'm going to subtract 23x from both sides. That's going to move all of my variables to the right, so I'm going to swing my constants to the left. 1 plus 19 is 20. And on the right-hand side, 27 take away 23 is 4. So now we're left with just one step. Dividing both sides by 4 will get x by itself. And we are left with the equation 5 equals x. If it really bothers you to see it that way, you can always flip it around because of the symmetric property. So x is 5. Our alternate exterior angles converse tells us that if x is 5, we know those two angle measures are equal. Therefore, the lines are parallel. Look at us doing proofs. Let's do one more example where we do not get congruence. Notice the two angles being pointed to are on the same side of our transversal. They are both below the transversal. Go ahead and highlight that. So they're below that transversal, that blue line, and they are between A and B. So these are consecutive interior angles. Consecutive because they're on the same side, interior because they're between the two lines A and B. So consecutive interior angles, but we don't want congruence there. Instead, we want supplementary. So 4x minus 5 plus 13x minus 2. Those need to add to 180. Again, 4x minus 5, that was my yellow angle. 13x minus 2 was the green one. The 180 is coming from the definition of supplementary. So this is another combining like terms problem. We have x terms, and we also have constants. So putting my two x terms together, 4x and a 13x will be 17x. Negative 5 and negative 2 is a negative 7. After combining like terms, we're just in another two-step equation situation. So we can add 7 to both sides. That will get rid of that 7 from the left, leaving me with just 17x. And on the right, 187. Last but not least, dividing both sides by 17. That leaves me with x on the left-hand side and 11 on the right-hand side. And there we have it, 10 examples of using the converses and some algebra. Note that the algebra we're doing is the same algebra we were doing on Thursday, but now we're using them in the context of the converse. This x value we find, has a slightly different meaning because it's an x that forces A to be parallel to B. Again, the reason why are consecutive interior angles converse. If you have questions or you need extra examples, let me know. Otherwise, practice is in the green packet. It's the very last page. We're almost done. Huzzah!